Here we have a several part question, and you can't see it, but it calls for using technology. However, I am going to show both calculating z-scores versus using normal CDF on the TI-84. We're told that the reading speed of second grade students in a large city is approximately normal, with a mean of 88 words per minute and a standard deviation of 10. What is the probability of a randomly selected student in the city that randomly selected student will read more than 93 words per minute? So if we use z-scores, I'll show you a calculation of that. We're going to have the 93 minus the mean of 88 divided by the standard deviation of 10. So we're looking up 0.5, but our shading is going to the right because we are asking for the probability that the randomly selected student will read more than 93 words per minute. My apologies, I went to open up the table and the question changed on me a little bit when I came back to it. Now the mean is 90, and we're looking for the probability that a randomly selected student will read more than 94 words per minute. So our z-score is going to be 0.4. And as I was showing in that graph, our shading is going to the right when table 5 is set up for going to the left. So let's see here. Looking up 0.4. Sure. Hold on a moment. All right, 0.4. We've got to go to the positive page. That 0.6554, I'm going to have to subtract from 1 using the fact that we're talking about complementary regions being shaded. Okay, so from z-scores and the table, we get 0.3446. However, as I said, I saw a dash T telling us to use technology. So we've got a lower bound of 94, keeps on going infinitely to the right, so we put in the largest positive number this can handle, our mean of 90, and our standard deviation of 10. And when that's rounded, that's going to round to the same thing, 0.3446, but I can't guarantee that's going to happen on all the rest of the parts. So 0.3446. Put that in, see what they think about that answer. All right, it's good. So if 100 were randomly selected, we would expect, multiply that by 100, we get 34.46, which would round down. That would read more than 94 words per minute. That's good also. Now, if we take a random sample of 14 of these second grade students? Well, we would calculate the z-score differently. We found that the mean of the sampling distribution of X bar is the same as that of the population, but the standard deviation compared to the standard deviation of the population, we'd have to divide by the square root of n. You want parentheses around the subtraction in the numerator and around that mini fraction in the denominator. So now we're looking at rounded 1.50. That's 0.9332. We're still talking about more than 94 words per minute. So that 0.9332, we're going to have to subtract from 1. Whereas if we use normal CDF, again, z-scores are not needed when you use normal CDF. You have to include here also that in a sampling distribution of X bar, the standard deviation is not the same as the standard deviation of the population. It's the sigma from the population divided by square root of n. And when we round that, that's going to round down to 0.0672. So if I'm correct about them wanting us to use the technology, we should be taking this answer. They are pretty close. They're only 16 ten-thousandths apart. So when we multiply that by 100, 6.72, that's going to round up to 7. We'd expect that 7 of those 100 would read at 94 words per minute or more. Sorry, not 7 students, but 7 samples. Now, if we bump that up to 28, the z-score place dividing 10 by the square root of 14 by dividing 10 by the square root of 28. Now we've got a z-score when rounded to 2 places, to the hundredths place, that's 2.12. Right here, 0.9830. That should be 0.017. Whereas if I use normal CDF, that will round down to 0.0171. So 100 simple random samples with the same size of n equals 28. Multiply that by 100, you get 1.71. That's going to round up. We'd expect in 2 of the samples that the mean reading rate is more than 94 words per minute. We saw the probability go down when you put larger numbers into square root of n. If you've had an algebra class, you know that the graph of y equals square root of x is an increasing function. As you go left to right, X gets bigger, Y is also going to get bigger. That's going to make the fraction sigma over square root of n smaller. The sampling distribution of X bar has less spread than the original population. So it would make it easier to find results in between two scores. Therefore, on the flip side, harder to find things outside in the tails. And we were looking at a right-hand tail. So the probability is getting smaller because sigma of X bar decreases as n increases. Looks like choice B is what we want. And that's good. The teacher instituted a new reading program. After 10 weeks, the mean reading speed of 19 of the students was 92.7. What might you conclude about this result? Well, Z-score wise, with 92.7, say mean of 90. But we have a sample size of 19. Again, remember parentheses around the subtraction in the numerator and the mini fraction in the denominator that you're dividing by. All right, Z-score. It's going to round up to 1.18. Looking at the table, 1.18. To the left of that, we would have 0.8810. Subtracting that from 1. Probability of 0.0119. Normal CDF wise, place that 94 with a 92.7. And again, we're going to the right. Okay, and the sample size was 19 now. That would round down to 0.1196. Either way, that number is not bigger than, is not smaller than 0.05. So she does not have an unusual result. She doesn't have much proof that this is a new reading program that's significantly improving. So the probability, taking what we get from normal CDF, rounds down to 0.1196. Yeah. Which means that if we did 100 simple random samples of the same size, 11.96, that would round to 12. Only 12 out of the 100 simple random samples of size n equals 19. And only that many would we get the mean reading rates of 92.7. So this is not abundantly more effective than the old program. Taking this good old time to check that. Give it a few moments. There we go. I think we have just one more part here. There's a 5% chance that the mean reading rates of a random sample of 25 second graders will exceed what value? Okay, well, 5%, 0.05. We looked that up in the table. Be very careful. You don't want 0.0005 or 0.005. You want 5%, so 0.05. And that's we have two of them, negative 1.64 and negative 1.65. So go halfway in between, negative 1.645. But that would be the bottom left when you go with negative 1.645. We want for the mean reading speed, we want it to exceed a certain number. So we use symmetry, go with positive 1.645. Remember, you've got a sample size of 25. So in your z-score formula, remember, you're not using the original z-score formula. That was for the individual scores in the population distribution. X has been replaced with X bar. Mu sub X bar, we know is going to be the same as mu. But then down here, not sigma, but sigma divided by the square root of n. And if this doesn't freeze up on me, we just found for the top 5% that we're going with a z-score of 1.645, our mean was 90 and a standard deviation of 10. But here they're talking about a simple random sample size of 25. Oh, sorry about that. So square root of 25 is 5, and 10 divided by 5 is 2. So we'd be solving, having x bar minus 90. Trying to get just this part to show up. Here we go. Equaling 2 times 1.645. Relax, key. Now 2 times 1.645. I'm not really concerned what that equals, because we can let the calculator do that, and then we'll add 90. So 90 plus whatever this is will give us the X bar for the sample size of 25 that we need to be in the top 25%. So I'm putting in 90 plus 2 times 1.645. Our other option, again, since this had the dash T that you couldn't see, we could go to inverse normal, put in that 0.05 with a mean of 90, and sigma was 10 over the square root of 25. Going to the right. Now, when that's rounded to the hundredths place, that's going to be the same thing. I want you to also notice this. If you have an older calculator, it only goes to the left. Doesn't even give you that choice. That distance away from the mean we could then add that to the mean to apply symmetry. So that instead of talking about 86.7 something scores below that, well, X bars below that would be in the bottom 5%. We can apply the symmetry this way to get the top 5%. So let's see here. There's a 5% chance that the mean reading score around the 2 places. So we found out either way that to 2 places we would get 93.29. Let's see if the other way. Yep, same thing. All right, here we go. 93.29 words per minute. And that is good. All right, more in a bit.